Hello Internet, and a special welcome to all of my 0 subscribers. Today we're going to have a little talk about jet engines.
Jets are behind many modern advances, from international commercial travel to the world's best fighter aircraft, and even the fastest car ever. But what are they? How do they work? Well, strap yourselves in because you're about to find out. My name's Ethan, and let's get right into the knowledge. Jet engines are, in short, an engine that provides thrust by accelerating a volume of air. This means that a force is applied to the air, and because every force has an equal and opposite force, a force is also exerted on the engine, which propels the vehicle. In a jet, air is accelerated through a four-step process: suck, squeeze, bang, and blow, or in more technical terms, intake, compression, combustion, and exhaust.
The first step is suck, or intake. This is usually accomplished by a fan at the front of the engine. As the fan rotates, it forces air from under the blades into the rest of the engine, while creating low pressure zones on top of the blades, which draw in additional air.
Once the air is inside the engine, it enters the compressor, where it is compressed by a series of compressor fans. After the compressor is done compressing, the air is now compressed. Because it is compressed, the air is at a higher pressure, meaning it will want to uncompress, or expand into uncompressed air, which would increase its velocity. Also, since compressed air is compressed, it contains more oxygen per unit volume, meaning it will combust with more energy.
After the compression stage, the air moves into the combustion chamber. Here, jet fuel is ignited in the compressed air stream. This reaction causes the air to heat up rapidly and drastically expand. However, since the walls of the combustion chamber are fixed, the air will exit the chamber at a higher velocity than when it entered. This stage provides the majority of the acceleration, and thus the majority of the thrust, but it also generates a significant amount of waste heat.
Finally, the high-velocity air exits the rear of the jet as exhaust. Often, this exhaust spins a turbine, which helps to power the rest of the engine. Sometimes, an afterburner is used in this stage. An afterburner injects more fuel directly into the exhaust stream, combusting it with the remaining oxygen. This causes the gas to expand even more, increasing the velocity and the thrust. However, afterburners use a lot of fuel, so they are used sparingly. Wait, this jet, and this jet can't all be the same, right? Right. While all jets use these same basic principles to generate thrust, not all jet engines are created equal.
In fact, there are 4 main types of jet engine: turbojets, turbofans, ramjets, and scramjets. There are also turboprops, which work similarly to jets, and pulse jets, which basically just explode fuel in pulses, but since these aren't true jets, we'll not go into detail. The first type is a turbojet, which is the basic jet. In these, all the air that goes through the intake is compressed, and all of it goes through the combustion chamber, meaning that all the air is accelerated a lot. These engines can provide enormous power over a big range of speeds, but since they must greatly accelerate the air, they are not very efficient.
Turbojets were the first jets to be built, and are mainly used in fighters and other military aircraft.
The next type is a turbofan. Turbofans have a large intake fan compared to their jet core because turbofans only compress and combust a small portion of the intake air. The rest is bypassed around. This makes turbofans very fuel efficient because you only have to greatly accelerate a little bit of air, while the bypassed air is accelerated only a little, but because more total air is accelerated, decent thrust can still be produced. However, these engines are inefficient at high speeds due to drag. Turbofans are mostly found on commercial airliners.
Finally, we have ramjets and scramjets. These jets are very similar, as both use rams to compress oncoming air rather than a standard compressor. Both of these jets have no moving parts, making them very simple. The only difference is that ramjets combust air at subsonic speeds, while combustion occurs in supersonic air in a scramjet. However, since they use rams for compression, both are very inefficient at subsonic speeds, with ramjets being useful between Machs 1 and 5, and scramjets operating above Mach 5. There are even plans to use scramjets to propel suborbital spaceplanes because they can operate at extremely high altitudes. I don't know about you guys, but that makes me think, what National Aeronautics and Space Administration? Hey, I'm just gonna stop now. That's all I have for you. Please consider joining my thriving community of subscribers or leaving a comment below. I'm Ethan, and thanks for watching.